Hello, this is Mr. Stansbury. I'm going to take you through the Unit 2A test form B problems. Okay, first one, factor the quadratic expression fully, x squared plus 6x plus 5. Now, if there's no number out in front here, we usually just take this 5 here and say, what are the factors of 5? 1 times 5, those are the only factors. And those factors are supposed to add up to 6, which they do. 5 and 1 add up to 6. We put x and x here. These two have to add up to positive 6, so that means that the signs have to be positive 5, positive 1, and this is it for factoring. Okay, that's all we got to do for this whole first section is just factor it out. Okay, number 2, as we look here, first thing we always want to ask, is there anything we can factor out of all 3 of those? Yes, we can factor a 2 out of all 3 of those, and that makes this problem so much easier. And if you try to do the little window pane factoring thing and you don't factor the 2 out, it will not work. It'll give you the wrong answers. So super important to remember to try to factor first. So this one over here, there's nothing to factor because that was a 1. But over here, again, we can factor a 2 out of all these. So we take that 2 and we leave it outside here. And that leaves us with x squared minus negative 4 times divided by 2 is negative 2x, and negative 16 divided by 2 is negative 8. Okay, now we try to factor this. Okay, we ignore this 2 and say, oh, there's a 1 out there, so we're just going to find the factors of 8. 1 times 8, 2 times 4. Which one of those have a difference of 2? 2 and 4 have a difference of 2, so we can simply just do this, x and x. The 2 factors are 2 and 4. And again, we can only do this little shortcut trick because this is the leading coefficient out here is just a 1. You know, there's a 2 out there because we already factored it out, so it means the leading coefficient of what we have left is just 1. So then we say, okay, these 2 have to add up to negative 2. So that means it's going to have to be negative 4 and positive 2. And that's the complete factorization of number 2. Okay, number 3. Is there anything we can factor out of 5, 14, and 3? No, we can't. So this is where we want to multiply the first by the last. 5 times 3 is 15. So now we come up with the factors of 15. 1 times 15. Let's see, 3 times 5, and I think that's it, isn't it? Yeah. So now we know that, let's see, now we got to find these factors here that have a difference of 14. 15 and 1 have a difference of 14. So those are the 2 numbers we're going to put into our little window pane, if you'll remember. Okay, so we make our little box here. 5x squared, whatever's the first term, always goes up in the top left corner, 5x squared. And then the last term always goes in the bottom right, minus 3. And then this 1 and 15 is going to be a 1x and a 15x. And then we got to make sure that we put signs in front so that they add up to be negative 14. So that's going to have to be negative 15 and positive 1. Okay. Now we find common factors horizontally and vertically. So this one here, 5 and 15 have a common factor of 5. X squared and x have a common factor of x. And then down here, 1x and negative 3 don't have any common factors. So if they don't have any common factors, we put 1. And then whatever this sign is in front of this first term here is what's going to go in between here. Okay. Now we factor vertically. 5x squared and 1x. Those both have an x in common. And then since this negative is right here, that means that this is going to be a negative in between these two. Common factors of 15x and 3 are 3. So then those are our 2 factors. So we get 5x plus 1 and x minus 3. And it does not matter what order you write those in. Okay. Oops. So next thing we're going to do here is we are going to look at the second section, 7.3. We're going to solve the quadratic by factoring. So we're going to do the same thing as we did up here. We're going to factor, but then we got to do one extra step by solving it because this now is equal to 0. Notice this is an expression up here where this is an equation because it's got the equal sign in it. Okay. So first thing, can we factor anything out of all 3 of those? Well, first thing we want to make sure that one side's equal to 0, which it is. and then now we say are there any common factors, which there aren't. So now that means we multiply the 3 times the 5 is 15. So we come up with the factors of 15, which are 1 times 15 and 3 times 5, right? And then we say which of those have a difference of 2. 3 and 5 have a difference of 2. So then we draw our little window pane thingamabob. All right. And the 3x squared goes in the top left. The negative 5 goes in the bottom right. And then the 3 and the 3x and the 5x go in the other two diagonals. And then we got to make sure we put signs in there so they add up to negative 2. So if they have to add up to negative 2, it's going to have to be negative 5 and positive 3. Okay? Now we do common factors. 3 and 3 have a common factor of 3. X squared and x have an x. 5 and 5 have a common factor of 5. And since this negative is right here, that's what's going to go right out here. So it's going to be 3x minus 5. And then 3x squared and negative 5x only have an x in common. And then 3x and negative 5 have nothing in common, so we put 1. And since this is a positive, that's going to go up here, x plus 1. So now what we have is we have x plus 1 times 3x minus 5. But remember, this all still equals 0. If we have two things multiplied together to equal 0, one of these things has to equal 0, because 0 times anything will give us 0. So what we have to do here, if you remember, is we got to solve each one of these for 0. So we do x plus 1 equals 0, and then we also do 3x minus 5 equals 0, solve both of those. Subtract 1 from both sides, we get x equals 1, or, and here we got to add 5 to both sides, and we get 3x equals 5. Divide both sides by 3, and we get x equals 5 thirds. So our two answers are going to be x equals 1 or x equals 5 thirds for number 4. Okay? Number 5, first thing we got to do is move this 2 over. Subtract 2 from both sides. 2x squared plus 5x minus 12 equals 0. Right? And then say, are there any common factors of 2x squared, 5x, and negative 12? 5 is prime, and those, yeah, so there's no common factors. So now we multiply the first by the last. 2 times 12 is 24. So I'm going to come up with the factors of 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. I think those are all of our factors of 24. And do any of those have a difference of 5? 3 and 8 have a difference of 5. So that's what's going to go into our little diagonals on the window pane thing here. 2x squared goes in the top left. Negative 12 goes in the bottom right. And then we've got, say, 3x and 8x. Remember, it doesn't matter which one goes where. It'll always work out in the end. But we do have to make sure that these two add up to positive 5. So in order for these two to add up to positive 5, it's going to have to be positive 8 and negative 3. Now do our common factors. 2x squared and negative 3x only have an x in common. 8x and negative 12 have a 4 in common, and this positive is going to go right in between here, x plus 4. And then we factor these two. 2x squared and 8x have a 2 and an x in common. And then 3x and 12 have a 3 in common. This negative is going to go right up there. So we end up getting 2x minus 3 times x plus 4 equals 0. So that means either one of these has to equal 0. So we solve them both for 0. 2x minus 3 equals 0. And we also do x plus 4 equals 0. Add 3 to both sides. 2x equals 3. Divide both sides by 2, and we get x equals 3 halves. Or we also subtract 4 from both sides here, and we get x equals negative 4. So those are our two answers. We get 3 halves or negative 4 for our two answers for number 5. Okay? Okay, moving on to number 6 and 7, solve the quadratic equation. So to solve this, we got to get x by itself. Really, the only thing we need to do to get x by itself right here is take the square root, because the square root of x squared is just going to give us x. Whatever we do to one side, we have to do to the other. Now, I'm going to do this in several steps, even though you can do this in one or two, but whenever you take the square root, make sure that you put plus or minus out there. That's the first thing you got to do. Okay? So, x is going to equal plus or minus, and then now with the negative, remember that turns into an I, and then the square root of 25 is 5. So you could write it like that. That's fine. X equals plus or minus I times 5. The little bit better way to write this is x equals plus or minus 5i. Okay? So again, the I comes from the negative inside the square root, and the square root of 25 is 5. That's where those two pieces come from. This one over here, we're going to eventually want a square root, but we got to get so that the whatever's being squared is all by itself on one side first. So we have to get rid of this 3. So it's negative 3, so we got to add 3 to both sides. X plus 2 squared equals 9. Now we square root both sides. So this square and square root cancel each other out, and we get x plus 2 on one side. Remember, whenever we square root something, plus or minus, square root of 9 is 3. Okay? To get x by itself, we have one last step. So what we got to do is we got to get rid of this 2. So we're going to subtract 2. Now, this is super important. Over here, this 3 is being added and subtracted. We're only subtracting the 2, so we don't want to do 3 minus 2. We want to put this negative 2. We want to squeeze that right in between the plus minus, right in between the equals and the plus minus. So really, this is x equals negative 2 plus or minus 3, because only the 3 is being added and subtracted, not the negative 2. Okay? So squeeze that out in front, and really what this is this means that we have x equals negative 2 plus or minus 3. So that means we get x equals negative 2 plus 3, and we also get x equals negative 2 minus 3. That's the plus and the minus of those. So we get x equals negative 2 plus 3 is 1, and also we get x equals negative 2 and negative 3 is negative 5. So those are our two answers for number 7. Okay. Number 8 and 9 says solve the quadratic equation using the quadratic formula. So the quadratic formula, in case you forgot, is right here, and you will have access to this when you're doing retakes. You do not have to memorize any formulas, so just not have to know how to use it. Okay, so here's our equation. We got to make sure the equation always equals 0. So in this one, it doesn't start off as equaling 0, so we got to move that 8 out of there. So we got to subtract 8 from both sides. We get 5x squared plus x minus 3 minus 8 is negative 5 equals 0. And then say, are there any common factors? 5, 1, and 5. Since this is a 1, there's not going to be any common factors, so we just leave it. And actually, since we're solving using the quadratic formula, you never have to find common factors anyway. So anyway, let's set up our A, B, and C, and then we can plug it in, and away we go. A is 5. B is, there's 1x out there, so B is 1. I've seen some people put x in there instead of 1s, and that throws people off a lot. But anyway, it's going to be however many x's we have, which is 1. And then C is going to be negative 5. So we get x equals negative B, which in this case is 1, plus or minus the square root of B, which is 1 squared, minus 4 times A, which is 5, times C, which is negative 5, all over 2 times A, which is 2 times 5. Okay? So in this one here, we get x equals negative 1, plus or minus, and then let's pull up our calculator to find out what's under our radical here. 1 squared we know is 1, minus 4 times 5 times negative 5, which gives us 101. So under the root we get 1, oh actually we just get 101 because we simplified all that. All over 2 times 5 is 10. Okay, so we can check and see if 101 simplifies at all. Do second square root 101, push equals, and as you can see this does not simplify, so we leave it like this. And once we get it all simplified as best we can, Then we ignore the root and say, is there any common factors? So this is 1, 1, and 10. So there's no common factors there. So this is our final answer, okay, for number 8. Okay. Number 9, make sure it equals 0, which it already does. And then, so now we know that A is 2, B is 4, and C is 9. So X equals negative B, which is 4, plus or minus the square root of B squared, which is 4 squared, minus 4 times A, which is 2, times C, which is 9, all over 2 times A, which is 2. So now we get X equals negative 4 plus or minus square root of whatever's under there. 2 times 2 is 4 is down here. So let's put that into our calculator. See what we get. 4 squared we know is 16. I always like to square this thing first because a lot of people, if this is a negative for your B, a lot of people end up getting a negative number for that and it throws them all off. So just do this one in your head. Know that it's always going to be a positive number because it's being squared. So we get 4 squared is 16 minus 4 times 2 times 9. And that gives us negative 56. Okay. So I want to see if 56 simplifies at all, the root 56. So I do second square root 56. I ignore the negative because I know that that's going to come out here. Negative 4 plus or minus. And I know I'm going to have an I out here. Right? That negative turns into the I. And then when I take the square root of 56, that gives me 2 root 14. So it's going to be plus or minus 2I root 14. Once I've got that all simplified with the roots, cover up the root and say 4, 2, and 4. Do those have common factors? And the answer is yes. You can divide all of those by 2. So our final answer is going to be all of these, the 4, the 2, and the 4 being divided by 2. So negative 4 divided by 2 is negative 2. Plus or minus 2 divided by 2 is 1I. And you don't have to put the 1 in there. You can just do the I. We leave the root alone. And 4 divided by 2 is 2. So that's our final answer for number 9. Okay? All right. 2 last problems to do here. 10 and 11. Find the discriminant and determine the number and type of solutions. Okay, so the discriminant, in case you forgot that, is B squared minus 4AC. That's our discriminant. So in this one here, it's already equal to 0, so we know that A is negative 2, B is 5, C is negative 10. So B squared, so it's 5 squared minus 4 times A, which is negative 2, times C, which is negative 10. And then away we go. So let's see, 5 squared this is going to be 25. Negative times a negative times a negative is going to be a negative. 4 times 2 is 8, times 10 is 80. So we end up getting 25 minus 80, which gives us negative 55. That's our discriminant. That's the first half. We also, that's why I put it in capitals, determine the number and type of solutions. As long as this is not 0, there's going to be 2 solutions, and then we have to figure out if they're if they're complex or if they're real. Since it's negative, that means that these are complex because this is going to end up with an imaginary number. So 2 complex solutions is what we want to come up with for the second part of that. Since it's negative, it's complex. Since it's not 0, it's 2. Okay, if this was positive 55, it would be 2 real solutions. Okay, last one, number 11. Make sure one side equals 0. So we got to take this 3 and we got to add 3 to both sides. And we get 2x squared minus 4x. And then negative 11 and 3 gives us negative 8 equals 0. You do not have to factor the common factor of 2 out. It will make it a little bit nicer, but I'm just going to do this without factoring it out just to show you that it'll work either way. When you're factoring, you do have to factor the common factor out. But since we're just plugging this into the discriminant, no need. Okay, A is 2, B is negative 4, C is negative 8, and we got B squared, B is negative 4 squared, minus 4 times A, which is 2, times C, which is negative 8. So negative 4 times negative 4 is positive 16. Negative times a negative is a positive. 4 times 2 is 8. 8 times 8 is 64. So 64 is 74. This ends up being 80 is our discriminant. Since it's not 0, that means there's 2 solutions. Since it's positive, that means they are 2 real solutions. Okay? All right, that's all we have for all the problems here on the Unit 2A test Form B. If you have any further questions on any of these, please feel free to ask in class. Thanks.